Hello everyone and welcome to this video. In this occasion we are going to take a look into how to model a truss here in Steamber. S-Frame has its truss generator, so you can quickly generate this kind of structures, but Steamber doesn't have this, so we'll take a look into how we can easily define a truss. This workflow I'm going to show you can be adapted to different geometries you may need. So first of all, let's define some grids. I'm going to generate. I'm going to name it by Truss grid and going for 10 grid lines at 2.5 meters and just one grid line at 3 meters. I'm going to click in create. Now I go to define grids, and here when it says elevation I'm going to write exactly the same that it's in the Y field. I click OK. Now here in the line type I can select Y and the grid is going to be shown like an elevation. So with this we can start defining our truss. I'm going to beams, select here for truss. I'm going to stick with this configuration about material and section, just change the method for chain and start defining the members. Now we have our chords model. You saw I jump one of the grid lines and you're going to see why in a moment. Now let's define the web for this structure. I'm going to go for maybe this section. Now we have our general shape defined. Let's take a look into the supports because this is something very important to note here. I'm going to select this node, and for the supports I'm going to select for fixed in translation because this is a truss structure. And for this one I'm going for custom degrees of freedom. I'm going to restrain this in the Y and Z direction, but I'm going to let it free in the X direction. For fixed, and the rotation is going to be let as free. Now we have our basic modeling done. Let's try taking a look into the loads. Now we're going to go to define load cases. We're going to add one, join load. We change the load type for live, click OK. Now we can start defining our loads. For this kind of structure, it's important to know that the loads that are going to be applied are the join loads. So for this, we select the join load and let's try for negative 8 kilonewtons. This one. Let's try for negative 5 here. And lastly, let's go for negative 3 in the center. So all of these loads are totally hypothetical. When you're working with this kind of a structure, it's important to work around the real loads and transfer them to the joints. Now we all of this, we're ready to go. So now we can click in Run and Analysis. I'm going to run this and we are going to save it as timber truss. The more run and we can see the different results. We're going to forces to see the forces in the X direction being the axial. We can go for the stresses. For the absolute, we can see the axial only. We're not going to receive anything from the shear X and Y. And this integrates all the results. But also we can try to run a code check into this structure. We're going for code check. We're going to run it, to save it. And as you can see here, we have our utilization. We can see two of the webs are failing, but the rest of the structure works just fine. We can try maybe trying to change our sections or maybe even running our design. It's up to you. And this is how you can easily generate a truss structure here on STimber. But we can also use the truss generator from S-Frame to create a structure that meets our needs, and obviously maybe having more complex geometry. Once you have everything ready, you can open it here on STimber. I have something prepared for that. So I'm going to open it. You can see here there is this pitch truss. File type is .tel. So that means it comes from S-Frame. I'm going to click and open. I'm not going to save this. And we have our structure. So for this one, maybe we can just try to work around the material. I'm going to try selecting a material that is stored in the database from STimber. Select, maybe for lumber, to click OK. OK. We'll work around with these specific sections. So we go for Run and Analysis. And as you can see, we have now our results. We can see into the forces. We can also see into the stresses, and so on. So this is how you can easily work with the truss generator to create a more complex structure. So it all depends of what you need. It's important to mention about taking a look into the sections, into the member type at the moment you're working with this geometry exported from S-Frame. But in general, you can follow the same workflow and work around the geometry that meets your expectations.